There are quite a few prompts to answer for this problem. The first is to identify the reactants, which are the compounds being mixed together in hopes of producing new compounds. Reactants will be found to the left of the reaction arrow, and in this case are magnesium iodide and silver nitrate. You will also see in here reactants referred to as reagents. Either term is equally valid. Reactants come together to form products, which are found to the right of the reaction arrow. For this reaction, silver iodide and magnesium nitrate are our products. They were not present in the reaction mixture initially, as they were not formed until the reactants were mixed together. A proper balanced equation will include states of matter, which describe the state of the reactants when they were mixed or the state of the products when they were formed. This reaction includes 3 ionic salts, which are dissolved in water, all indicated by the notation AQ following their chemical formulas. Silver iodide is the only solid species. I know this because of the S included after its formula. Our balanced equations include information on the ratio of reactants required to form products, or the products formed from the reactants, etc. This information comes in the form of the coefficients found in front of each chemical formula. Notice that there are 4 boxes included, though there are only 2 actual numerals typed into the equation. Molar values of 1 are implied and therefore won't be included in our equation. Any 2 things in a balanced equation can be related to each other through their coefficients to give a mole ratio. Perhaps you need to know how much product, in this case silver iodide, to expect knowing that you've added a certain amount of magnesium iodide, the reactant, to your mixture. For every 1 mole of magnesium iodide that reacts, 2 moles of silver iodide will be formed. We will use these mole ratios to quantify our reactions in the next module. There, we will want to write our ratios in fractions forms so that it better drives our calculations. Again, any 2 species in a balanced equation can be related through their coefficients. It will require 2 moles of silver nitrate to produce 2 moles of silver iodide. This particular ratio can also be simplified to 1 mole of silver nitrate producing 1 mole of silver iodide, and that would be equally correct. But in general, I will use the coefficients as they appear in the equation and will not reduce them when performing my calculations. Lastly, it's important to remember that all of our balanced equations tell us a story, and we can read them all like very short, kind of depressing fairy tales. This particular tale states that when a single mole of aqueous magnesium iodide and 2 moles of aqueous silver nitrate are added to the same reaction vessel, 2 moles of solid silver iodide and a single mole of aqueous magnesium nitrate will form as products.